रिएक्शन चैप्टर का नाम है। तो सबसे पहले ना इसमें जो फर्स्ट टॉपिक है ना, ज़्यादा टॉपिक्स है नहीं इस चैप्टर के अंदर, ठीक है ना। मेनली इसमें हम इस चैप्टर को 3 से 4 टॉपिक में ला सकते हैं। जैसे पहला हो गया टाइप्स ऑफ रिएक्शंस, साथ ही में फिर इसमें हो जाएगा बैलेंसिंग ऑफ केमिकल रिएक्शंस, और उसके बाद एक टॉपिक है इसमें बैलेंसिंग ऑफ, ये सबसे इंपॉर्टेंट टॉपिक है, बैलेंसिंग ऑफ इक्वेशंस, बैलेंसिंग ऑफ केमिकल रिएक्शंस। और उसके बाद एक टॉपिक है इसमें रिडॉक्स रिएक्शन, और लास्ट में है एप्लीकेशन ऑफ रिडॉक्स रिएक्शन। ठीक है ना। तो रिकॉर्ड होता रहेगा, लिखने की एज इट इज कोई ज़रूरत है नहीं, रिकॉर्डिंग में आपको भेज दूंगा, आपके पास भी रिकॉर्डिंग रहेगी। एप्लीकेशन ऑफ रिडॉक्स रिएक्शंस।
अ,
ठीक है।
एक सेकेंड, ये जो मैं बुक यूज कर रही हूँ ये लक्ष्मी सिंह वाला चलेगा ना?
हाँ, कोई भी ले लो, लखमीर सिंह ले लो, चाहे कोई भी ले लो, एनसीईआरटी ले लो, लखमीर सिंह ले लो, सब में यही कंटेंट है।
ओके।
ठीक है, अभी मैं पूरा अपना एक ओवरव्यू समझा रहा हूँ, फिर इसके नोट्स भेज दूंगा आपको। अब देखो, अगर हम बात
ओके।
करें सबसे पहले टाइप्स ऑफ रिएक्शंस की, तो टाइप्स ऑफ रिएक्शंस में हमारे पास होते हैं टोटल 4 तरह के रिएक्शंस होते हैं। ठीक है ना, बड़े इजी इजी से होते हैं। मैं बैलेंसिंग भी साथ साथ ही सिखा दूंगा, बहुत इजी होती है। अब जैसे कि सबसे पहली कैटेगरी क्या है, कॉम्बिनेशन रिएक्शंस। तो कॉम्बिनेशन रिएक्शंस जैसे नाम से ही पता लग रहा है, कॉम्बिनेशन रिएक्शंस क्या होते हैं, जिसमें कोई एक या दो चीजें या तीन चीजें मिलकर कोई एक चीज बना दें। व्हेन व्हेन वन और मोर सब्सटेंस combine together to form a single product. Okay, जैसे C plus O2 gives CO2, Mg plus O2 gives MgO। अब आप देखोगे जो मैंने ये MgO वाला रिएक्शन लिखा है ना, ये बैलेंस नहीं है, क्योंकि यहाँ पर आप देखोगे कि इसको रिएक्टेंट कहते हैं, इतना आपको सबको पता होना चाहिए कि जो एरो से पहले है वो रिएक्टेंट होता है, और जो एरो के बाद है वो प्रोडक्ट होता है ना। तो रिएक्टेंट और प्रोडक्ट में एटम का नंबर ना बिल्कुल सेम होना चाहिए। तो आप देखोगे नीचे यहाँ पर 2 एटम है ऑक्सीजन के, लेकिन यहाँ तो एक है ना। तो आपको क्या करना पड़ेगा, बैलेंस करने के लिए नीचे यहाँ नहीं लगा सकते, क्योंकि ऐसे नीचे यहाँ लगाने से तो मॉलिक्यूल की आइडेंटिटी चेंज हो जाएगी। तो हमें 2 लगाना पड़ेगा यहाँ पर। उसके लिए मैं डिफरेंट पेन ले लेता हूँ बैलेंसिंग दिखाने के लिए। ये मैंने देखो 2 लगा दिया। अब लेकिन यहाँ 2 लगाने से मैग्नीशियम अनबैलेंस हो गया, तो यहाँ भी 2 लग गया। अभी बैलेंस रिएक्शन है। सो इफ एनीबडी आस्क यू व्हाट इज अ कॉम्बिनेशन रिएक्शन, यू कैन सिंपली से दैट व्हेनेवर टू एटम्स, टू और मोर reactants combine to form a single product. There are many examples. There are many examples like CaO plus CO2. It will change into CaCO3. There are many examples. Okay, but the thing is that all these kind of reactions are, you need, the point need to be noted is that combination reactions are always exothermic. Okay, combination reactions are exothermic reactions, means whenever molecules combine with each other na, then heat is always released. All these reactions accompanying by release of heat. Okay, heat is always released. So like this is like there is no different category for exothermic and endothermic reactions, but exothermic reaction, like combination reactions, are always exothermic, because whenever molecule join together na, so they become more stable, and when the thing become more stable, then heat is released. Okay, so these are the various examples of combination reactions. And so in the textbooks there will be more examples than this, but the concept will be the same. Okay, now coming to the second category, which is the decomposition reaction. Okay, now as the name is suggesting itself, decomposition reaction means when the reverse of combination is happening, like AB is changing into A plus B. Okay, again, so now obviously there will be some energy required to decompose a thing. It will not decompose by itself, so energy is given in the process. So we call this kind of process as endothermic reactions. Okay, so all exothermic reactions are exothermic. On the other hand, the decomposition reactions are endothermic, because energy is required to break the things. So now energy can be given in 3 ways. Number one, energy can be given in the form of the normal heat. So we call that kind of reaction as the thermal decomposition reaction. Okay, the thermal decomposition reaction, again, the name is suggesting itself. Thermal means heat. So when decomposition is being carried out by giving heat. Okay, and the other category
Mhm.
is the photo decomposition. And again, photo means light in the science side. So photo decomposition means when energy is given in the form of light, and the other category is of the electrolytic decomposition, where energy is given in the form of electricity. Okay, so there are three
Okay.
kind of decomposition reactions. I'll give you examples of each. Like thermal decomposition have many examples. Like if you give heat to the calcium carbonate, then it will change into this CaO plus CO2.
Mm.
And in case of photo decomposition, photo means light, because
Mm.
energy is required to decompose the things. So suppose you are
Mm. Mm.
decomposing AgBr, and it will change into
Mm.
Ag plus Br2. So you need
Yeah.
to
Mm.
understand this thing, that Br will always be written as Br2 when it is written alone, because Br always exists as a Br2. So in this case,
Mm.
BR is unbalanced. So we need to balance the BR. But as I told you, we cannot apply 2 here, because it will change the identity of the molecule. So
Mm.
we will
Mm.
apply 2 here only. There is no option of
Mm.
there is no other option. So but now after applying 2 in this side, AG is unbalanced in the product side now. Can you see? So
Mm. Yeah.
now
So
what
we'll
to do
apply
in this
to.
case, what we
Mm.
can do,
We'll.
we can balance this by okay.
Mm.
Okay, so we can like put a 2 over here. So now this is only
Mm.
example of photo decomposition, and the other example is AgCl, where Cl, Br and Cl are like quite close friends, like because they belong to the same group. So a Br and Cl can be
Mm.
interchanged. So this you need to understand. In case of electrolytic decomposition, there is only one example, that when heat is given to water, it changes into hydrogen plus oxygen. Again, this reaction is I wrote this reaction in the balanced manner only because of my habit, because I always write the reactions in the balanced form. So but still hydrogen is unbalanced. You can clearly see that hydrogen is
Mm.
unbalanced there, so I will apply a 2 here.
Mm.
So this
Mm.
chapter of chemistry is really easy if someone like understand this for a time. And balancing is the most important thing. For a 10th class student, balancing looks difficult, but when a person is mature, the
Exactly.
balancing looks so simple. So there are many examples, like here also. There is a chemical called ferrous sulfate, FeSO4, and if you
Mm.
heat it,
Mm.
it changes into
Mm.
uh,
I see.
Fe FeO plus SO2 plus SO3, and I think it will be Fe2O3. So again, we need to balance this reaction, and this FeSO4 is green, having green color, because they also ask this kind of questions, that if some substance is green, we give heat to that, and then it changes to two gaseous products. Okay, so and one more thing,
Mm.
that whenever in brackets G is written, it stands for the gas. Whenever S is written, it stands for a solid. These are very basic things. Okay,
Okay.
so now if I
Okay.
apply 2 here, is it balanced or not? 2Fe, oxygen is 8 here, and oxygen is, yeah,
Mm.
it's a completely balanced reaction. Okay, now
Right.
moving towards
Mm.
the one more category of this decomposition reaction, like lead nitrate. We have lead nitrate. Two molecules of lead nitrate will changes into 2 PbO plus 4 NO2 plus O2. These are the three best examples of nucleophilic substitution. And one more thing that you need to understand, that NO2 gas is brown in color. Okay, and
Okay.
all these are the examples of the decomposition reactions. Moving forward towards the next category, which is called as the displacement reaction. Okay, so in case of displacement
Mm.
reaction, as the name is suggesting its nature itself, that a reactive metal can displace the less reactive metal. So here the A is displacing the B, and we are getting B alone, and A is joined with the C. So like if
I'm
zinc
sorry.
is
I'm sorry. Can I just a second? I'm sorry. for interrupting, but in this book there are experiments given
Yeah, experiments are
point
of these
wise.
reactions only. Experiments are of these
Okay,
reactions only. Like these are given in the form of activity. Okay, so the result of
okay,
those experiments are the same. In the
okay,
these reactions are being given in the experiment form. I'm just telling you,
okay,
there
okay,
is
okay.
nothing which I'm leaving.
No, no, I
All
just
these
asked.
things, yeah,
Yeah,
all
yeah.
only these things are given in the form of reaction.
Okay,
Once you go through the book na, then you will understand that all these reactions are given in the activity form, nothing new. Now suppose like this is reaction, can you just tell me what is the result of this?
sorry.
Can you just
What?
tell me what is the result of this reaction? Can you just guess by looking at the theme of the reaction number?
Wait.
What gonna happen according to you? Just see it carefully.
Just a second.
It's really easy.
ZnSO4
Yeah, perfect, very good. ZnSO4 plus copper.
plus copper.
Yeah. So these are the displacement reaction, and mind you
Okay,
that reverse cannot happen because like zinc is more reactive than copper, so the reaction is
okay,
going in this way. But suppose if you take reverse like copper and ZnSO4, then you won't get any result because
okay.
less reactive cannot displace the more reactive one, as simple as that. Okay, and copper sulfate has a blue color. That's why I'm keep on telling you the colors also, because in those activity, no, they are more,
Huh.
they are giving these colors and all, so they have like exemplify these reactions in the form of activity. That's why I'm just telling you the colors, because in the activity they will make the question in the tricky way. They won't ask you the questions in the straight way. They will ask the question in a tricky way, that why, like somebody has taken a blue crystal and that blue crystal changes into a faded one, then can you guess the reaction or the nature of the reaction? They'll ask you like
So
this.
we have to learn the colors also
Yeah, that's why I'm telling you
of
na.
the.
That's why I'm telling you.
Okay,
Yeah.
okay, okay.
Like now coming to the other reaction of this category again, zinc plus AgNO3 gives. So again, can you guess the reaction?
It will be zinc nitrate
Yeah, zinc nitrate, perfectly all right. So
and silver. No, is it okay?
yeah. Well, you just need to remember the right formula. That will be ZnNO3 whole 2 plus
Hmm.
Ag.
Ag.
Okay, so yeah, it's as simple as that. Now come going to the other
Hmm.
category, which is the double displacement reaction. Like in the book there will be more one to more example, but once you get through this thing na,
Yeah.
so
There are many
yeah,
examples actually.
but all the examples are based on this theme only. Like instead of
Yeah,
taking this
yeah.
ZnSO4, they will be taking FeSO4. Okay.
Okay, yeah,
So the
yeah.
thing is that you need to be like more concerned about the theme or about the basic concept. Examples can
Okay,
be many. Double
okay.
displacement reaction. In double displacement reaction, exchange of ions occurs. Exchange of ions occurs. So what's gonna happen in this? Like this is AB and this is CD. So what's gonna happen? Like this A plus B minus C plus D minus. So the reaction will be AD and BC. The reaction will be AD plus BC. Now just following this theme, I'm just giving an example. Like this is suppose NaCl and this is BaSO4. So can you guess the product of that?
And then so forth.
But the thing is, you need to understand the valency concept. Okay,
Okay, the
NaSO4 does
valencies.
not
Yeah,
exist.
yeah, yeah,
NaSO4 does
yeah.
not exist, nor does this BaCl. BaCl2 exist in the nature.
Okay.
Okay,
Yeah,
so
yeah,
this is
yeah.
the thing which you should understand. And one more thing, that in these cases, a precipitate is formed. A precipitate is something which is an insoluble substance. So these kind of reactions are also called as the precipitation reaction. PPT, you understand na? Something which is insoluble. Suppose you are mixing two
Yeah,
transparent
yeah, yeah.
chemicals and finally you are ending up having a white thing below the test tube or beaker, then we call that as a precipitate. So in double
Mm-hmm.
displacement reaction, generally a precipitation reaction occurs. Okay. So right now, what I have done, that you can clearly see one thing, that again, that this two sodium and there is one sodium, so we need to balance by putting a 2 here, and by putting a 2 here, it's
And we
balanced.
also need to remember the valencies, right?
Yeah. So valency is, if you have the class ninth book, na, it is
And
given in the table
yeah.
3.6, chapter 3. So you just remember the all the valencies and formula
Okay.
making, then only you will be perfect in chemistry. Once you are like perfect in writing the formula, then chemistry is really simple.
But there are a lot of in this book there are a lot of complex reactions given. So many reactions are there.
What I'm telling you, that like double displacement. I can also write 3 4 more examples of this. Like suppose you just tell me what I'm saying, that you stick to the basics. Now examples can be many. Like just
No,
let me.
no,
Can you
no,
tell me the
yeah,
answer of this?
no, no.
Can you tell me the answer of this?
Again, there will be AgCl2
Yeah.
and
AgCl only. AgCl only.
NaNO3,
AgCl only, because
NaNO3.
Ag has the valency of 1.
Okay. Hmm.
So
Hmm.
examples can be many, na. Like we can make
No,
any
no, no,
example
no.
for
I
this.
wasn't saying that. I was saying that there are many complex examples given, so we have to practice
what
that
you
now.
do what you do whenever you come across these kind of complex example, now you WhatsApp me that, now I'll explain on the video message, sorry, audio message.
Okay. Okay.
Okay. So for according to me now, I have done with this types of reactions and also balancing of reactions, because side by side I'm also explaining the balancing concept.
Mm-hmm. Hmm.
Although there will be 50 60 examples of balancing, but balancing is done by hit
Yeah.
and try
Right.
method only,
Yeah.
na. So this
Yeah.
thing is to be practiced only. Like this thing is a
Okay.
practice thing, na? Balancing is by in case of instructions, when you're giving TV and you're teaching, balancing is a 1 minute thing. But when you're practicing, like in the NCRT, I'm just telling you in question, balancing questions. Question number 5, 6, 7, 8 are based on balancing. And if you
Hmm.
do these balancing questions, na, then you will be perfect in doing
Hmm.
balancing. And types of reactions, like whole NCRT back exercise is based on the types of reactions only. And types of reaction is like
Yeah.
really easy to
Yeah.
understand. Combination, decomposition, exothermic, endothermic, and displacement and double displacement, really easy to understand. And some conceptual questions are also there, like where magnesium ribbon should be cleaned before heating. So we say that magnesium ribbon should be cleaned because it has a layer of oxide. And there is some question that this chemical is used in whitewashing. So like these kind of questions are kind of memory based.
Okay.
Okay.
We have
Now
to.
coming to the other category,
Just a second. Okay.
you just tell me.
There is one more reaction now, oxidation and
Yeah, I'm just
reduction.
coming to that category only, na? That is redox reactions.
Huh?
Okay.
Okay. Yeah.
Very simple concept, redox reactions. Okay, the second last topic of the chapter, redox reaction, really simple to understand. Red means reduction and ox means oxidation. Really simple. Oxidation, as the name is suggesting itself, oxidation is addition of oxygen only.
Hmm.
Addition of oxygen or removal of hydrogen. You can take like oxygen and hydrogen is a rival of each other. And
Hmm.
like if suppose oxidation is addition of oxygen or removal of hydrogen, then what could be the definition of reduction? Addition of hydrogen or removal of oxygen. Are you getting this?
Yeah. I'm getting just in between your voice is cracking.
So can you simply read this na? Like reduction. What is reduction? Addition of hydrogen atom. What is oxidation?
Addition.
Addition of
Yeah.
oxygen.
Or.
Like just give. Let me give an example of this.
Hmm.
Like this is CuO plus you are adding hydrogen into it. So what's gonna happen that
Hmm.
copper will be getting alone and it's H2O now. So you can
H2O.
clearly see
Hmm.
that copper has lost oxygen.
Hmm.
As copper has lost oxygen,
Right.
it
Right.
reduction
Right.
occurs na? Because removal of oxygen is what?
Hmm.
Okay, and similarly, hydrogen is getting this oxygen, na? So this is oxidation. And one
Okay.
more thing
Yeah.
that when the substance which undergoes reduction act as an oxidizing agent. Act as an oxidizing agent. So in this case, the CuO is acting as an oxidizing agent, and the substance which undergoes oxidation acts as a reducing agent.
Can you please repeat it once more? I'm sorry.
I'm
Couldn't
telling
hear you.
that a thing which undergoes
Reduction.
reduction acts as an oxidizing agent, and the thing which is
Okay.
undergoing
Okay.
oxidation acts as a reducing agent.
Yeah. Reducing agent.
Okay,
Okay.
it's really
Okay.
simple, really simple.
Hmm.
Okay,
Hmm. Hmm.
so
Hmm.
and the last top like redox again in the case of redox reaction, there will be many examples. Like in the yesterday, I taught the students about this reaction. Na plus H2O is changing to NaOH plus H2. So this is 2, 2, 2. I think this is balanced now. And
Hmm.
now we need to understand that which thing is getting oxidized and which is getting reduced. So Na is
Reduce.
getting NaO, na? So it is getting
Hmm.
oxidized.
Hmm.
And H2O,
Oxidized.
in case of oxygen, is
H2O is
lost.
get.
So it is getting
Hmm.
reduced. Okay.
Getting reduced. Yeah. Yeah.
हाँ? क्या हुआ? हाँ? Might be 2 मिनट बाद होने वाली है. Now, the coming to the last topic, that is the application of redox reaction. So in case of application of redox reaction, very simple. Two applications are there. Number one is rancidity, other one is corrosion, which is really general. In case of rancidity and in case of corrosion, it's really simple. What is rancidity? The oxidation of oily food. Okay, oxidation of
Hmm.
oily food.
Hmm.
When oxidation of oily food, na, we get smell uh, of like we get smells of oil, like foul smell comes from the oily food due to oxidation. That's why the chips manufacturer fill nitrogen in the chips packets. Are you getting this?
Oh.
Rancidity is means oxidation of
Hmm.
oily food, and rancidity means when a foul smell comes out from a food, when it is kept like in open for some days and it has some oil.
Okay.
So
Okay.
it
Okay.
generally occurs
Yeah.
now back when you are going somewhere and finally you are ending up taking something of low quality from a vendor, and then you realize that it is giving a foul
Yeah.
smell.
Yeah.
Yeah, so
Hmm.
and that's why nitrogen is being filled in the chips packets. You must have observed that in the Ruffle Lays packets
Yeah.
or in,
Yeah.
so there are a lot
Yeah.
of air.
Hmm.
Why they fill lot of air? Because obviously they need to preserve their oil na, by
The
filling
foods.
nitrogen,
I know.
so that
Yeah. Yeah. Yeah.
oxygen should be prevented from to coming in the contact with the chips.
Hmm.
Okay.
Hmm.
In case of corrosion, what is corrosion? Like we must have understood about the rusting of iron. Actually what happened that whenever a metal comes out to be in a contact with the oxygen, metal changes to metal oxide, and metal oxide is not that strong, and metal oxide
Hmm.
you can say metal oxide is like strengthless. It doesn't have that strength. Like suppose iron is getting
And
oxidized and
start
changes
resting,
to, yeah.
and then start resting.
Yeah. Like what is rusting in simple manner? whenever a metal comes in contact with the oxygen and moisture, it changes to oxide or hydroxide and loses its strength. And
Mm.
once the metal loses its strength, then it is of no use, no? Because
Mm-hmm.
we are using metal for its strength only. Like we are using iron because
Yeah.
it has a lot of strength. But now we don't
Yeah.
use iron that much. Rather, we use steel more because steel cannot get corroded. So
Yeah.
what is corrosion in simple terms? Like when silver articles gets black, this is also a example of corrosion. Silver
Mm.
articles gets oxidized to a blackish substance. Are you
Yeah.
getting it?
Yeah.
So, but the gold is
Yeah.
that precious metal which does not undergo oxidation and
Defense.
remain
Right.
like shiny always. That's why it's a so precious metal.
Mm.
So, for me,
Yeah.
according to me, this is the complete overview of the chapter. And the like once you once go through the chapter, this chapter is content wise. This chapter is this much only. Okay. So I'll give you worksheets. I will give you
Okay.
notes also, like complete notes,
Mm.
but the main concept, the main overview of the chapter is this. So, as I told you, it will be I will take half an hour for this completion of this chapter. You can see on the, I think it's 25 minutes, 26 minutes now.
Yeah. Exactly.
Okay. So I've recorded this chapter, I've recorded this thing. I'll put this on YouTube also. So you can get the
Okay.
recording of this from my side also, and I think you have also recorded. So you just have a look
Mm.
on the books also. Whenever you come across something which is like completely going over the head, then you can just ask me.
Okay.
Okay. Okay. Thank you.
Mm. Mm.
Bye.
Yeah. Thank you. Bye.